In this programme, we are looking at two computer systems. A very large, fast ICL 2972 used by the BOC Datasolv Computer Bureau, and a Kremenko microcomputer running a computerized employment exchange. What they have in common is an operating system, and we'll be seeing what that is and how it works. But first, let's look at the employment agency. We start with a girl looking for a job. Like most people, she's seen an advert in a newspaper. But what happens now is unusual.
Hello, Jobline.
Carol's call is answered here, a phone-in agency in Stokenchurch near High Wycombe, where all the job details are on computer file.
It's the Reading Chronicle, you say? Righty-ho then. If whilst we're getting this information up on the computer, you could give me a few details about yourself. If we could start please with your name. Kendell? Yeah. Right, and your address please, Carol.
The Jobline agency keeps an up-to-date file of vacancies, matching applicants to jobs like any agency.
Yes.
Age, experience, qualifications.
Right, have you any particular qualifications at all? Can I have your address?
Do you have any sort of qualifications at all? I'll take you back a bit now. Can you remember the subjects?
And what the applicant wants. And that includes the geographical area too. The Jobline territory is arranged in 8 areas, and each job is coded accordingly. Area 7 is towards Slough, 7-6, the town of Henley. Carol used a reference number to apply for a particular vacancy, but that one's not the right job.
They haven't really got the experience that they're wanting. They're wanting 2 to 3 years of management experience, which you haven't really yet had. And they're also wanting the full qualifications. But if you'd like to hang on a second, we'll see if we can find something that's more suitable for you. All right, if you'd like to hold them.
But this is where an up-to-date computerized filing system can help. Searching is done by codes. 25 main categories, from office work through to forestry and miscellaneous. Carol wants something in accountancy. Code 6. And within that code, a range of subcodes to specify the job in detail. And you can specify salary and the location of the required job.
Oh, this one's even better, actually. This one's actually in Henley, which is going to save you all the travelling right on your doorstep. They want a part-qualified accountant. You'll be working with a team to provide management with details controlled by which business performance can be assessed, analysing historical results.
So that's what Jobline do. And speedy access to the data files is crucial for each of the 3 girls. So what sort of computer equipment do Jobline need? Now this is the Jobline computer system. It consists of 3 terminals next door, a printer, which you can then print out the copies of the job file, and the computer system itself. Now this computer system is based on a small microcomputer. And inside here we have a processor, working storage, and backing storage. Now the job file itself is actually held in backing storage. It's held in this, a floppy disk. With 1 terminal, 1 processor, and 1 disk unit, handling inquiries is straightforward. The program, held in working storage, reads the typist's request, calculates where the data is held on disk, and issues a request for it. The data is copied back into working storage, and finally the program transfers the data onto the screen. But at times during the day, the volume of inquiries is too great for 1 operator with 1 terminal. Now Jobline calculated that 3 terminals would give a good service. One way of getting them is to have 3 identical computer systems. But Jobline don't use 3 systems. Why not? The trouble is, Jobs are being added to the system all the time. If this job, now being added to the files, isn't available to the other screens,
Self-employed freelance?
there's a problem.
TV engineer.
Terminal 1 could be reporting that there are no suitable vacancies just when Terminal 3 is adding a new job to its disk. Whatever else happens, all three users need to share the same data. In Jobline, sharing data means sharing the same computer.
Now the key to seeing how resources can be shared in the computer can be gained from looking at how the computer is used. Now when Janice typed in a query onto the Jobline files, it seemed that it took only a short time. But in that few seconds that the query was typed, that processor was idle because the program was not being executed. You may think it took only a few seconds, but in that time, many thousands of instructions could have been executed.
To see how this helps us to share the computer, we need a closer look. There's one program for each terminal, and also the operating system program. Now we'll see the role of the operating system in a moment, but what are the other programs doing? A request from Terminal 1 causes the program running that terminal to send off to the disk for data. After a pause, the data arrives, and it's sent back to Terminal 1. If Terminal 2 wants data, it can be fetched in the same way. When the program isn't processing requests, the processor is idle. While data is being retrieved for Terminal 3, Terminal 1 may ask for more. Waiting for the first request to be satisfied, there's spare capacity. The processor is idle, and it can be used to issue another request for Terminal 1's data. And when the data comes back, there's a problem. Which terminal wants the data? Deciding how to share resources is the job of the operating system.
Well, we came to Jobline for two reasons. First of all, the application is relatively simple, and therefore the operating system should be relatively simple to understand. And secondly, we can, in a sense, see the operating system working. Now I'm going to show you some of the working storage of the machine. Now the working storage is contained in these 4 cards. They're divided into blocks. This is one block, the integrated circuits that hold the working storage. This card holds one copy of the Jobline program. This card holds a second copy of the Jobline program, and this card contains a third copy of the Jobline program. These are all equivalent to each of the girls sitting in the terminal room typing. Now this block contains an important piece of software known as the operating system.
And on the 3 terminal cards, the flickering of the lights shows when the operating system passes control from one program to another. It's the operating system program that's running whenever the system is otherwise idle, constantly checking to see if any of the programs is ready to run. If one is, that program is given control of the processor for a period of time enough for it to issue a request for data. That request is passed to the operating system, which retrieves the data from the disk. And while the operating system waits for the data to come back, it continues to check to see if another program is ready to be given a share of the processor. If another request comes in, that program is run and more data requested. The operating system is always in control, marshalling data requests, sharing the computer resources. And when data comes back, the operating system stops checking programs and decides where to send it.
And at the moment you're working. How much notice do you have?
Matching jobs needs the human touch, so that's not computerized. The computer just acts as one big filing system.
It must be O-level standard.
In fact, Carol will be on Jobline's books until she's accepted a job, and her records are put into the archives.
Check the invoices.
So that's Jobline, a simple, reliable system for entering or searching for jobs. The Jobline operating system is small and efficient. It knows roughly what to expect in the way of work. What happens when you've no idea what to expect? The operating system of this computer has to solve exactly that problem.
Well, we've come to BOC DataSolve, which is a computer bureau that exists to sell time on their ICL 2972, a very large, powerful and expensive computer. So it's in their interest that they get maximum utilization from their resources. Now, jobs coming into the computer come via this room, either via cards or via terminals, and sometimes over communication lines attached to the place of work of their customers. Now, the wide variety of their customers is reflected in the wide variety of jobs that come into the computer. Some jobs are small, others are large and may stretch over many trays of cards. Some jobs require a lot of file input-output time, and others require very much more processor time.
The ICL 2972 has an operating system, but it has a lot more to cope with than the Jobline system. DataSolve's system uses a wider variety of peripheral devices. 8 of these magnetic tape units, for instance, and 14 of these exchangeable disk drive units. No one user needs all of them, but in a bureau system it's important that users don't share each other's data. And output is by one of the 2 high-speed line printers.
Now, the operating system of the 2972 is very complex. It took hundreds of programmers some years to produce it, and it would be foolish of us to attempt to explain its workings to you in any detail. So what we're going to do is to take a job and look at its progress through the computer, from the card reader to the line printer, and see how the operating system actually interacts with it. Now, here's a small job that DataSolve have produced for us. What it does is to take one of their files and print out the contents. The job will be run under the job name M252. Now, since we're not clients of DataSolve, they've allowed us to run it under the username CUST1, which is their customer services division. Well, the cards have been read in. Now, the next question is, where is our job now?
Our job is the last of 4 in a queue of jobs, waiting for resources, like working storage, to become available. The casual viewer can read less from this display than from eavesdropping at Jobline, but then only the operators need this information. This queue is priority 3. It costs customers more to be in one of the higher priority queues, since that gets the job started sooner. At Jobline, there was no queuing up. So handling queues is one extra task for a part of the 2972 operating system, the high-level scheduler. Another screen displays the minute-by-minute record of what jobs have been allowed into the computer. At 12:13 and 14 seconds, there were enough spare resources for M252 to start. It beat the other 3 jobs out of the queue because it was smaller and needed less resources. But now it's time to take a look at the whole system. The 2972 has many peripheral devices for its users. Tape units, disk units, line printers, and more besides. Our job only needs a fraction of the 2972 resources. The operating system allocates us a section of working storage, finds our file on disk, and assigns us a line printer. But we're not the only job. There are 4 screens like this one, listing currently active jobs. Our job is in the middle. J20 is just an identifying tag for tracking the job through the system. There's too much information here to describe fully. Let's look at 2 other typical jobs from this list. Job 7 is a file update program. Only the UPD part of the job name is any clue to that. But that's what the user NMIS chose to call the job. It's using tape units and some working storage, but no disks or printers. Back on the screen, we can see that it started as long ago as 9:10, and at this moment, its status is R. It's running in the computer. Job 8, an inquiry program, is also running, which sounds like a contradiction. It's using a lot of disks, and there's enough room in store to fit both 7 and 8 in together. In the same way that Jobline shared the processor between programs, the 2972 operating system will share its processor and will switch between jobs in order to use the processor efficiently. That's scheduling, an operating system task that we'll return to. But there's another problem now. There's no room for any other job in working store. So where's the rest of this lot? We can see by inspecting job 20, our own M252. Right now, its status is S, which means swapped out on the fixed head disk. Now that's one peripheral we haven't yet mentioned. The very high speed fixed head swapping disk, solidly cased and rotating in a nitrogen-filled atmosphere. Let's forget the other peripherals and see how the operating system uses the swapping disk. All of the jobs, not just the few we show here, are kept on this disk. 7 and 8 are in working store, but there are still copies of them on the disk. Choosing which job runs next is the operating system task that we're coming back to. But at some stage, the choice will fall on our job, job 20. It has to be in working store to run, so something has got to move out. The operating system chooses, and let's suppose it's 7 that has to go. The latest version of the program goes out onto the disk, overwriting the older version. And job 20 takes its place. After a while, the operating system chooses to stop job 20 and to start another. If it's number 8, nothing needs to be moved. Another job, and it has to be moved in. Not enough room, something has to go. We're beginning to get a picture of how many decisions a complex operating system needs to make. At any moment, jobs are running while others are swapped out. All the time, the operating system is choosing which runs next. So how is the choice made? There's another queue in the computer, a queue of jobs in the order that the operating system will run them. Job 7's at the head, so it can run. It runs until it wants data from one of its tapes. The operating system requests the data, just as it did in Jobline, and then Job 7 is suspended, waiting. Job 8 is next to run, but before it starts, the operating system adjusts its queue. Job 7 goes back. How far down depends on its priority, but the operating system takes care of this. Now Job 8 runs. If it isn't interrupted by an input-output request, it's executed for a fixed time, and then the operating system halts the job and sends it back down the queue. In this way, everyone gets a share of the processor, executing their job one piece at a time. Our job runs in the same way, for a slice of time or until it's interrupted. Each job gets its chance, and if there are transfers to be made, the operating system is in control.
Our job is currently being executed on the machine, and what it does is to print out on this line printer the contents of the DataSolve file. Now here lies another problem for the operating system. There could be a large number of jobs requiring a printer which are being executed at the moment. Now DataSolve only used 2 printers. So here is an example of yet another resource that has to be shared.
There's a lot that needs printing out. This is the list queue summary of all jobs that need something listed on a line printer. M252 is there. Again, there's a lot of information. We can see that the job came from the card reader unit number 20 and that it uses standard line printer paper, not special forms or multi-part carbons that the operator would need to load. So there's all of these to print. Who organises it? Well, that task is undertaken by a piece of software we've already seen on the job queue. Job 3. The master program running the line printer unit 10. It's been running since just after the system started up at 9 o'clock in the morning. And, like all other jobs, the operating system has been swapping it in and out. Right now it's running. As each output file is prepared, it's stored on the disk to await its turn at the printer. And having done that, M252 is complete. And almost 6 minutes after starting, it's finished. There's only the printing left.
The results of the BBC's National School Software Competition will be announced in an hour-long edition of Micro Live this coming Sunday morning at 12 o'clock on BBC One. Daytime on 2 continues.